So this is the equivalent circuit of a synchronous machine, and I will show you how to find the electrical power, both active and reactive. So the electrical power that we want to find is on the right side here. The electrical power would therefore be SE is equal to the terminal voltage multiplied by the armature current. And this is a per phase equivalent circuit, which means that we need to multiply by 3. But we normally don't know the armature current, so we need to find an expression for the armature current. So we can write the armature current as the voltage drop over the impedance divided by the impedance. So the voltage drop is EF, and I'll write this bar over because EF is a vector, and the same applies for almost all of the other values as well. Minus VT bar, and then divided by the impedance, which we just set to set, just to simplify. This is also a vector. So now we just put this into the equation for the power. Just delete this like that. In order to find the active power, we need to find the real value of this expression here. So in order to do that, we first need to simplify this expression. So V, the terminal voltage, is equal to the absolute value multiplied by the angle, which is 0 because the terminal voltage is real. And then we have the internal voltage here with the angle, which is delta, and then minus V terminal. I just write V terminal for now. And then we can say that the impedance has an angle of theta. We can further simplify this to the V terminal, just remove that angle. And then we can split this into 2. So we have the internal voltage over Z, and then the angle here becomes delta minus theta. Then minus V, so we have V terminal over Z here as well, but here we have minus theta. And now we get that the power is equal to 3 terminal voltage multiplied by the internal voltage divided by Z. And then we have the angle here, which is delta minus theta. And for the other one, which is multiplied by 3 terminal voltage, which leaves us with this. And the angle minus theta. If we now want to find the active power, it should be pretty easy. It is 3 the terminal voltage multiplied by internal voltage over Z, the impedance. And then we just take cos over this angle. And then we do the same for the other parts. And cos with minus theta, which is actually just theta. But this is actually not the power that we use for the synchronous machine, because we can simplify it even further. If you look at this equivalent circuit here, we have this impedance, that is XS plus RA. But most often, this XS is much larger than RA. So we can set theta equal to XS, which means that theta would be equal to 90 degrees. So now we can also rewrite the cosinus part. So if you have a angle alpha minus 90 degrees, this is equal to sine of alpha. So we can also replace that for the equation below. So the power would be equal to 3 VT EF divided by XS, and then multiply by, now we get sine delta. And then this last expression here would just be 0 because we get sine of 0, which is 0. If we do the same simplification as for the active power, we get 3 and the terminal voltage multiplied by the internal voltage over XS. And now we have sine delta minus 90 degrees, right? So this should be equal to minus cos delta. So we can write that in. So we get a minus cos delta here. And then it's the same here. So minus times minus equals plus. So we get 3 and the terminal voltage over XS multiply by cos 0, which is 1. So that is just 1. And we can also move this minus sign in front